Okay, good morning. If you remember, we were talking about the sets, operations on sets. We learned about four operations. One, the complement operation. So if I have a set A, then I can talk about its complement. And then if I have two sets, I can talk about the union of two sets, which means this set consisting of all elements which are in the universal set, but X is either in A or in B. Of course, it might be the case that X belongs to both of them. And then we talked about the intersection, means the set of consisting of all those elements in the universal set which belongs to both of them simultaneously. X belongs to A and X belongs to B. And then before the break, actually, we learned another operation, which I told you that I will denote it by this usual difference notation, but in the book they have written it in this form. Okay, they are the same thing. And this, if you remember, means the set of all elements in this U, which they consist of all the elements in the universal set which belongs to the first set but do not belong to the second set. So these are the only operations we have in set theory here. For example, we already discussed quite a lot about the union and intersection, but let me just remind you about this. For example, if I give you two sets, A is 1 and 2 and 3, B is 2 and 3, 4 and 5, we can talk about what is the set A minus B. So the set A minus B, you need to check for all the elements in A that are not in B. Yes? Not the other way around, so don't get confused. So when I say A minus B, I need to see that, okay, 1 is in A, but it is not in B, so I consider it as an element of A minus B. But 2 is in A, it is also in B, so I do not include it here. 3 is in A, and it is in B, so I do not include it here, so I close it. So A minus B is this set. I don't have anything to, so some of the students I have seen, they also include 5 there, but this is not correct. And then if I ask you what is B minus A, so B minus A means the set consisting of the elements in B that are not in A. So you start with the elements in B. So 2 is in B, it is also in A, so I exclude it. 3 is in B, it's also in A, I exclude it. But 4 and 5 are only in B, but not in A, so I include them. Yes? So this is the definition of the difference of two sets. And then there are some of them are actually very trivial. For example, if I give you two sets, if I give you one set and I ask you what is the subtraction between these two sets, this means the elements in A which are not in A. So this cannot happen. So it means that there are no elements left. So that's the empty set. Yes? I don't know. For example, if I say what is A minus the empty set, what is the answer? Means all the elements that are in A, but they are not in empty set. But not being in the empty set is not a constraint at all, because nothing is in the empty set. So the answer to this becomes what? A. But, so what is this one then? So what is this one? Yes? There is no negative A, so that's what I intentionally write that. There is no negative A in the set theory, yes? So what is that one, yes? The empty set. So this tells you that you need to choose elements from this one and then make sure that those elements that you are choosing from this one are not here. But there are no elements here that you can choose. So let alone that there you have another condition. So that's also empty. Okay, for example, what is the universal set minus a set? Yes?
Was it a complement?
It's the complement of A. So why is that? Because it tells you that all the elements that are in the universal set, but they are not in the set A itself. So that's exactly the definition of the A complement. So what is this one then? A minus the universal set.
Zero set.
There is no zero set. The empty set, yes? Okay, so there is one important result here. Usually, this is a good relation that you need to remember, okay? A minus B is equal to A intersection with B complement. So this means that whenever you want to talk about the difference of two sets, you can translate the difference operation to intersection operation, but the price that you have to pay is that instead of working with the second set B itself, you have to work with the complement of that set. Okay, this is in the book, but they have asked you to understand it from a Venn diagram point of view. So let us understand, okay? So we need, if you want to investigate an equality in set theory, you need to have two exact copies of the same picture. It's not easy to do it here by hand, but we can pretend that they are exact copies of each other. And then in general case, let me take this set A, let me take this to be set B, and I will do the same thing here, A and B. So we pretend that they are carbon copy of each other, yeah? Okay, so what is A minus B? If I want to highlight A minus B, means those elements that are in the universal set with two properties. They should be in A, but they should not be in B. Yeah, they shouldn't be in B. So what should I write? So where should I highlight these parts? Yes, these are the parts that you see are in A, but they are not in B. So this indicates A minus B. And now on the right hand side, I need to intersect between A and B complement. To do this, I need to find B complement first. So let me just change my color. So B complement means outside B. So let me just try to color it in that way. So whatever is outside B is B complement. Yeah, so these are the outside B. So this green part is B complement. So then I want to find the intersection between this green region and the set A itself. The set is this circle. If I ask you, where do you find the intersection? Where is the overlap? The overlap is exactly here, yes? Because if I want to draw the overlap, so you see, I want to highlight the points which are inside this circle, but also being colored by green. So hopefully you agree with me, this is exactly inside this border. Yes? These are the only, whatever is inside, of course. These are the only points which are both in A and they are colored green as well. And then if you compare that blue part with this orange part, they are exactly the same region. So that's one investigation. It's a good justification why these two be equal. But if you want to prove it mathematically, let us just do practice because your book is not clear. Sometimes they ask you to prove these things. So if you want to prove that two sets are equal, do you remember what we are supposed to do? Yes?
We have the same element.
So if you want to elaborate a little bit more, how should we do that?
Well, every element in A is in B, could also say.
No, this is not complete. That's what I'm saying. If every element of one set is in the other set, it doesn't mean they are equal. It means the first one is a subset of the other one.
Oh, okay.
Yes? Yeah.
Was it that every element of A corresponds to the same element in B?
No. You need to be very precise in the words that you choose in set theory, yes? So if you want to show that two sets are equal, if you show that whatever in C is also in D, it is not finished, because this then means C is a subset of D. But you also need to show that whatever in D is in C. So in order to prove that C is equal to D, you have to prove two things. Once, as you mentioned, we have to prove this, but we also have to prove this. Okay, so now here I have two sets. One of them is A minus B, the other one is A intersection B complement. We want to show that these two sets are equal. So it means that I choose an element here, an arbitrary element on the left-hand side, from the left-hand side, and convince myself that yes, it is also in the right-hand side. But then it is not finished. Then I have to reverse the logic. Okay, so let us start with this. So I would say let X be an element in A minus B. We show that X belongs to A intersection B complement. Yes? Okay, how should I do that? I start with my assumption. Okay, you are telling me that X belongs to A minus B. What can I conclude from this? What can I conclude based on the definition of the difference of two sets? If someone tells you that X belongs to the difference of two sets, what can you conclude? Yes?
X is not in B.
Okay, why? Of course, this is correct, but this is why did you choose that X is not in B?
Just the first thing I thought of.
No, but the first thing that you need to think of is the definition of A minus B. Yes? If X is not in B, there is no guarantee that X is in A minus B. Yes? Because, for example, here, if I choose this point is not in B, but it is not in here either, yes? So X belongs to A minus B means what? You are killing me, what? Yes? Yes?
X belongs to A and X does not belong to B.
Yes, this. That's the definition I just told you here, right now, yes? A few moments ago. So X belongs to A and X does not belong to B. Yes? This is the meaning of X belongs to A minus B. Yeah, I don't know why it comes to mathematics, you think in a very different way. Yes? So, okay. X belongs to A and does not belong to B. Okay, I do not have any problems with X belongs to A, but if I tell you that, okay, X does not belong to B, if you want to, you can conclude something, yes? If X does not belong to the set,
It's in its complement.
in its complement, yes? And now, someone tells me that this X simultaneously belongs to these two sets. On the one hand, X is an element of A, and on the other hand, X is an element of B complement. What can I conclude about this X? Where is it at the end? Of course, it is in A, it is in B complement, but it is also in, yes? Intersection, in the overlap. So it means that X belongs to A intersection B complement. So we reached the goal, yes? I started with an arbitrary element. This is a representative element of whatever here. Then I showed that if you accept that X belongs to A minus B, according to the definitions that we have set up earlier, you have to accept that X also belongs to A intersection B complement. But it is not finished yet, because so far it shows that A minus B is included here, but it might be this one that is bigger. So we have to show that no, it is not bigger. Okay? Let us try to understand it the other way around. So in principle, you should say let x belongs to A intersection B complement. We show that x belongs to A minus B. But let us be lazy a little bit and not write too much. If x belongs to A intersection B complement, do you think that I can reverse this arrow and go back? Yes, I am telling you that x belongs to the overlap of two sets. What is the logical consequence of that is that this x belongs to both of them. So this means x belongs to A and x belongs to B complement. So from here, I can go back here. But from here, do you think I can go back there? X belongs to A and x belongs to B complement. So of course, when x belongs to A, still I can say x belongs to A. But if x belongs to B complement, I can say that x does not belong to B. So this is also reversible. And when this is the case, I can go back again because that is the definition of A minus B. Yeah, so that is correct. So it means that whatever here is there, whatever here is there, so that these two sets have to be equal. Yes? For example, this topic is operations on set, even though this type of problems is not in your book, but they are not that hard. Let us do some of them. For example, what do you think will happen for this? I just want to draw your attention. This is why in your book they write it like this. Yes, why is that? Because I just want to emphasize this is completely different from normal algebra. If A and B are numbers, what is the answer to this, by the way? If A and B are numbers, not sets, what's the answer there? Yes? No? It's always mistake, yes? B. Yes, minus sign goes in, and then it becomes B. But it might be true that the answer to this is B or not B. But the point is that you're not allowed to think in this way to answer this question. This is why might be the notation in the book is better. Because when I write them in this way, you are somehow tempted to simplify things as if they are numbers. But they are not numbers, okay? So how can I simplify this? By the way, can you guess whatever, if you want to guess something, don't do that guess. That is most of the time wrong. But if you want to visualize it, it's a good idea to visualize it using the Venn diagram. So can you tell me what is this one using the Venn diagram up there? Yes, at the level of your course, you really need to understand this using Venn diagram. So A minus B. So what is the answer? This part is A minus B.
This is the intersection between A and B.
So, yes?
Is it A intersection B? Like more in the middle? Oh, I don't know.
Okay, no. The answer is not that part. Yeah, might be the answer is that part, yes. So you said what? Intersection?
Yeah.
You mean,
A intersection.
you mean here,
Yeah.
the intersection between A and B. So I think it's correct. Yes, because what does it mean? It means, this difference means I am interested in all the elements that are in the first one, but they are not in the second one. Yes? Okay, so it means that I am interested in the points within A, but they are not in the orange part. So what is left? Exactly as you said. Yes, you are right. This part is left. And that part has a name, yes? What is the name in set theory for that part? That's the overlap between A and B, which is A intersection B. So by this, you really can guess. This is at the level of your course. So you should be able to do it correctly. So you see that if you mistakenly write the answer to this is B because you are thinking this algebra form, that turns out to be wrong in set theory, okay? So be careful. They are not comparable at all with the number algebra. So it might be the notation that's used in the book is better than mine, but it becomes riskless if you really understand what is going on. So that is the diagram shows us, that is the answer. But if you want to do it a little bit more advanced way, you can do it in this way. I mean, it is a little bit hard, but I want you to understand. I just tell you, it is optional. So if I want to do this algebraically and in a rigorous way, what can I do? We just proved that this relation holds. For the difference of two sets, if I want to, I can repeat the first set, and I change difference to intersection, but I have to be careful to complement the second one. Okay, so if I start here, I copy and paste for the time being the A part minus, but instead of A minus B, what can I write? I can write A intersection B complement, yes? So let me write, this is optional. Okay, now can you help me to continue? I want to use this theorem once more because I have another subtraction here. So what can I do? Can you tell me what to do? Now this whole thing is playing the role of B. Yes? So I have A as I have there, I have minus as I have there, but this second one is playing the role of that B. So what can I do? I repeat the first one. I change this to intersection. Yes? And then what should I write? What should I write? Yes?
So in parentheses, you would write A in intersection B complement and then complement.
Exactly, thank you. Yes, is that understandable? Okay, but I don't know if you remember, we studied this before. There is a rule for this algebra. Do you remember what was the name of that, or how does it read? So it was De Morgan laws, yes? So this was a level 3 problem in the book without mentioning the name of the person who actually the law goes after him. And the De Morgan laws are these laws, yes? If I have two sets, I union them, and then I want to find the complement, I can separately do the complement, but be careful, you have to swap these to intersection. And if you start with intersection, you can do them separately, and you want to complete the intersection, you can intersect, you can complement the individual sets, but then if this is intersection, you have to change it to the union. So if you go back and check the videos, we solved that problem because this was a level 3 problem in the book. Both we did it using the Venn diagram and then using this method of rigorous proof. Okay? Okay, so which one is suitable for our case? Because I have two sets intersected and then I want to make a complement out of it, so I can use the second rule, yes? So what can I write now? So I copy and paste this part, and then I complement these individually. Yes? But the price that I have to pay is to make it into a union. Yes? Okay, but can I do some algebra here again? Still we can continue because there is a better name for B complement complement. What is that? It's B. So I would write A intersection A complement union B. Yes? But do you remember there is a rule also here, yes? One of them is intersection, the other one is union. We learned that intersection is distributive over the union, and union is also distributive over intersection. So I can take this and distribute it inside. So what is the answer? It becomes A intersection A complement. Yes, A intersection with B. What is the notation? What is the symbol between them? Yes? What? Union. Yes? So that is distribution law. Okay, but there is another way I can still simplify. What's the answer to this part? A intersection with its own complement is any set overlap with its complement, empty set. So this is the empty set. So this becomes the empty set, and then I have the union, and then I have A intersection B. Now, someone has given me a set. I union that set with the empty set. What do I get? A intersection B. So that is the mathematical proof of that trivial result. Okay. So this is the set algebra, but this is optional. I told you if you don't like it, you don't need to learn it. Okay. So this one. There is one more topic left, and that is talking a little bit about the cardinality of sets. Okay. So you know that the cardinality of a finite set means the number of elements in that set. Now the question is that, and then I told you that you use the same symbol as you use for absolute value. But of course, if I have absolute value of 2, it is clear that I am talking about a number. So absolute value of minus 2 is 2. But if I write absolute value of 1, 2, 3, here, I do not mean absolute value. What I mean cardinality of this set, which is the number of elements in that set, which becomes 3. Okay? Now, the question is that if I have two sets and I union them, if I want to know the cardinality of two sets, so in this topic, I am talking only about the finite sets. So A and B are finite sets. Okay, we want to find a relation for the union, the cardinality of the union of two sets. The first impression might be that, okay, I count the number of elements in A, I count the number of elements in B and add them. Do you think this formula is correct? Yes? No? It might be wrong. For example, can you give me an example? For example, let us take A to be what? 1 and 2. And let me take B to be 2 and 3. Okay, if I ask you what is the union, by the way? 1, 2, 3. But you don't repeat 2 times, yes? So if I ask you what is the cardinality of A, you will tell me 2. What is the cardinality of B, you will tell me 2. But if I ask you what is the cardinality of A union B, you will answer 3. And it is clear that if I add these two, it is not that. Okay? So now, can you fix this formula for me? So the cardinality of A union B, we realize that, by the way, this is always wrong, or sometimes it might be true. Is it always wrong to write this?
No.
When it is true?
When they have no...
Nothing in common. Yes, that's correct. So, but now, can you fix this formula that is working all the time, yes?
Minus A intersect B.
Yes, minus not A intersect B, minus
The cardinality.
Cardinality of this. Yes, so that is the correct formula for this. So if I ask you what is the cardinality of the union of two sets, you will tell me that the cardinality of the first one plus the cardinality of the second one minus the cardinality of the intersection of two sets. Of course, we will say that cardinality of A union B is equal to cardinality A plus cardinality B if and only if A intersection B is empty. And there was a name for that. Do you remember? This means that A and B are disjoint. I'm just reminding you this word. Okay. Another thing is there is also another exercise in the book. They want to talk about the cardinality of union of three sets. This I want to discuss about that and then give you two examples and the lesson will be finished. So the set theory will finish today actually. And then we start another topic next time. Okay, so what do you think will... So let me just, by the way, draw a diagram for you. It was not very surprising that this is correct. So this is the universal set, and this is A, and this is B. It is clear that if I want to count the number of elements here, when I count the number of elements in the first circle, I am also counting this part. Yes? When I am counting the elements in the B, I am also counting this part again. So I'm just counting this piece 2 times. So I take one part away so that I have the correct answer. Now, what is your guess about the cardinality of three sets union? Yes, so for example, my question is about this. So if I have the three sets, all of them finite, and I ask you, can you write a formula for the cardinality of the union of three sets? So what is your guess? For example, I think you agree with me that the answer to this question becomes a little bit harder. And even imagining it from the Venn diagram point of view, yes? So if I have three sets, in general, three sets might look like this. Yes? So I want to find a formula for that. Yes?
Is it maybe the cardinality of A plus the cardinality of B plus the cardinality of C minus A and B's intersection cardinality and the cardinality of the B and C's intersection and A and C's intersection and ABC's intersection?
You were 99% correct.
What did I miss?
Yeah, I mean, so what you said is this. The answer is cardinality of A plus cardinality of B plus cardinality of C minus cardinality of A intersection B minus cardinality A intersection C minus cardinality B intersection C, and then minus in cardinality A intersection B intersection C.
Yeah.
That was your answer. Yes? So 99.9% is correct. Is there anyone to fix it? So for example, you see, let me give numbers. So here is M. Assume that M is the number of elements in this part. Yes? Let me write X, Y, and Z. So X here, Y here, Z here, T here, U here, for example, M here, and N here.
Maybe you don't
Yes?
need the last one.
So here, I want to find the sum of all of them. Let us check your formula, okay? So by X, I mean the number of elements in this part. By Y, I mean the number of elements in this part. By Z, I mean the number of elements in this part, and etc. Okay, so let me start by the formula that you mentioned. If I want to write A, so I want to write your formula. Cardinality of A is what? Can you tell me according to this picture?
X.
X, no, cardinality of A, the whole A, is X plus Y plus Z plus T. This is the cardinality of A. Okay? And then the cardinality of B is what? Y plus Z plus U plus M. Yes? And the cardinality of C is U, Z plus U plus N plus T. So this is the first line. But when I say minus, so by the way, what is my goal to find? My goal is to find X plus Y plus Z plus T plus M plus U plus N, yes? When I ask the question mark, this is my question mark, because I want to know the number of elements inside these things. I hope that you agree that this is not complete yet, because you see, for example, I need one z, but z appears 3 times. So when I add them, I have two extra z's. Yes? So this is why you thought about subtracting in the correct way. Yes, you are right. So let us subtract. A intersection B. What is A intersection B? Includes two parts, y and z. So it becomes y and z in total. The next one is what? A and C. A and C. Where is that part?
T and Z.
T and Z. And then minus what?
Yeah, Z and U.
Z and U. Okay? Okay, so let us try to understand that. Okay, so but and you said minus A intersection B intersection C. Where is that?
Y,
Just
Z,
this,
E,
no,
and
all of them
oh,
intersection.
Z.
It's just Z. Okay? So you said subtraction. Okay, but let us check. You see, this is positive y, this is positive z, this is negative y, negative z. So they are really gone. Okay, remember, I want to be left with this. Okay, and then t and z, can I cancel them? For example, here t, negative t, and this positive t are gone. This negative z, for example, by that z is gone. And then negative z will cancel that positive c. Negative u will cancel this positive u. Okay, let us see what happens. I am left with x, good. And I am left with y, good. And I am left with m, that's also good. And then I am left with u, that's also good. And then n, yes. And then t, yes. So far z is left. And then what is here?
And then yeah, you need a positive C.
You need a positive c. So your answer should be this. Yes? Is that understandable? So that is the formula. So was it clear? It's not hard. I mean that you need to sit down and be patient and then do calculations. Okay, but of course this is not a proof, because you might say that, okay, how do I know that the sets are connecting like this? Might be I have different scenarios. I have to check all the cases. But you can prove it rigorously, but I think it's beyond the actually your lesson, but it doesn't mean you cannot understand that. So we have two formulas, one of them for 2 sets, one of them for 3 sets. But this is not usually the questions that you face in the exam or in the book. You want to solve these kinds of problems. If we solve these two problems and the lesson will be finished, okay? Okay, so let us, for example, solve that problem. So these are kind of questions you have in the book. There are some of them are very good, by the way, in the book. Some of them are tricky. So this is a very simple one. There are 35 students in a class, 15 students play football, and 23 students play basketball. If 5 students play neither football nor basketball, how many play both? So some questions like that, okay? So let me write the information on the board, then I will actually take it. So there are 35 students. The total number of students is 35. Yes. And then 15 of them play football. Is 15. So I don't know how to write simply. The number of football players are 15. So the number of basketball players is how much? Is 23. 5 students don't play neither, so they are just enjoying their lives. Yes, and then we want to see how many of them play both. Even though you can use formulas, but I really don't recommend you to do that. I would recommend you to draw a Venn diagram for yourself. Okay, so what we do, we consider the universal set here. The universal set here is the whole class. Okay, this is my universal set. And then I have two sets, two subsets in my universal set. Some people play football, so you can just visualize it by drawing a circle and put F on it for football. And then basketball, also you can just draw another circle and put basketball. And in general, you need to overlap them because apparently the question is about how many people are actually here. That's the point, yes? Okay, even though you can start writing formulas, I don't recommend you. This is the way that I recommend you. This is what you want to understand, so I would put X there. Okay? This I know X. First of all, I know that 5 students don't play at all, so 5 elements are here. 5 elements are outside football and basketball, but still they are a member of the classroom, of course. The question is to answer what is the number of players who are playing both football and basketball. I don't know that, I put it X. But then, what is left for this part? I know the total football players, the whole football players are 15. X of them are here, so what is left here is 15 minus X. Yes? And then what about this part? What about that part?
23.
23 minus
X.
X. This is what I know. On the other hand, I know that 15 minus X plus X plus 23 minus X should be how many? Because the whole number of students in the class is 35. 5 of them does not play any game. So how many is left? 30. So this is a simple equation and you solve and find your X. This method is better try to write the formulas, especially you will see it in the next problem. I want to wait for you to solve it for you. But this is very simple. X and X are gone. 15 and 23 becomes 38 plus X is 30. And X becomes what? Oh, I got a negative sign. So how is that possible? Oh, sorry, I made a mistake. This is minus X. This X and X are gone, minus X is left. 15 and 23 is 38, is 30. And X becomes 8. So 8 students are playing both of them. Yes? So X becomes 8. Okay, but now I want to wait for you to solve that problem for me. So, I mean, some of the problems in the book is more complicated even than this one. I want to give you time to see this one. You have to do it once to learn, okay? So read the problem, hopefully it is clear. Yes?
Why is 15 in letters and 23 in numbers?
What?
In the first question example.
No, because usually if you want to write mathematics, it is not too good to start with a variable.
Okay.
Yeah, so this is grammatical. When I want to write 15, and you see that I have a period, I do not start with 15. So in mathematics, you usually do not start with the number in figures, or you don't start with x. For example, if I talk about function f, and then I say that f is odd, this is not a good sentence if before that is a full stop. I will definitely start with the function f, write some words, and then f. This is how mathematicians actually work. And of course, even in English, if you want to write 2, it is preferable to write 2. But if you want to write 82, then you write 82. That's it. Okay. Okay, so I want you to work on this for 10, 12 minutes at most. Probably you might need your calculator. I don't remember the numbers, but let me read the question, by the way. In a school with 380 students, 215 are taking biology, 173 are taking physics, 182 are taking chemistry, 72 both biology and physics, 90 both biology and chemistry, and 60 both physics and chemistry. If 9 students don't have any of these courses, God knows what they are doing then, how many students are actually taking exactly one subject? So I mean, if you just want to write the formula, it will not help. So it is better to try to analyze the problem. I don't remember which problem in the book was very nice for me even. I mean, might be when you are starting, that was probably an A-level question. But this is one question that you should be able to solve. They are not, by the way, hard, but you have to be patient. Okay, I pause the video and wait for you around 12 minutes. Okay, so could you solve the problem? Let me start. Let us start solving it together, okay? So I have written the information here, but the interpretation is yours actually. So here, of course, we have 3 subjects. So let me just draw this universal set here. And then we have 3 subjects. So here it is biology, and then it is physics, and then we have chemistry here. Okay, so the number of people who are taking biology means that the whole circle for the biology includes 215 students, and the whole circle for physics contains these many students, and the same thing for chemistry. But can you tell me which part of it is wanted? Yes, do you have questions?
Yeah, why can't we assume that there are students that take all 3?
Why we can't?
No, why do you assume that there are students that take all the 3 courses?
No, this is the most general case. If it happens that there are no such a student, then it turns out to be 0 in your calculation. But from the beginning, if you exclude that possibility, that might not be close to reality. So that's why, that's a good question, by the way. How should I know about this? I mean, this is just something for visualizing the borders, okay? In that case, that there are no such a student, it means that is 0. And then that's, if that is the case, calculation will reveal that is equal to 0 at the end, yes? Yeah. By the way, is it possible that we don't have that? Yes, it is possible. You are right. Might be this is the scenario. Of course, we draw the circles, of course, but might be this is biology, this is physics, and then I have this situation. Yes, something like this. And then this becomes chemistry. So you are right. Then I have an intersection between chemistry and biology. I have an intersection between chemistry and physics, but there are no students. But if you consider this, it means from the beginning you have pre-assumed there are no such students. Yes? But in the case that I do it, if it is going to be 0, the calculation will reveal that this number is 0. So by drawing like this, I have 2 possibilities in front of me, and then the calculations will show which one is the case. But if you assume that, it means for some reason you already know that there are no such students, which might not be correct. Yes, and of course, if you assume that and then start calculation, you will probably get nonsense answers. For example, you might get the number of students here is -5. Then you realize your assumption is wrong. That will happen. But that was a good question. Okay, so let us now try to solve the problem. First of all, can you tell me what is the question mark here? Which part? Because if you go back to the slide, how many students are taking exactly one subject? They are not taking. They are not asking how many of them are taking only one physics or chemistry or only, for example, biology. So, which part of the diagram is wanted in this question? Yes, do you want to answer?
Isn't it all the parts that are not intersecting?
Yes. So it means that this, let me just show it here. The number of students here are the students who are studying only biology. And the students here are the students who are studying only physics, and the students here are the students who are studying only chemistry. So the sum of these three parts is wanted in this problem. Is that clear? Okay. By the way, they might ask you some probability questions here. For example, they give you this information and they say that, okay, we pick a student in random. What is the probability of that student studying only biology? So these kinds of questions they can also ask. Okay, so then it means that you need to find the number of students here, the total number of students are also given, and then you write the ratio of these number of students, then you have the probability. I think in the book you have some kind of this kind of questions. Okay. In the language of set theory, for example, if I want to write this, instead of writing so many letters for biology and physics, the number, what can I write, for example? I can write the intersection between biology and physics, cardinality. Yes? So this expression can be summarized in this form as well. Okay, so let us try to solve it. I don't know what the answer is, but 9 is outside every subject, so we have 9 students here. 9 students is outside. I don't know. For me, it's better to start with the middle one. I don't know what is that, so I call it X. Okay? We still don't know what X is. And then we don't know. Okay. But, of course, I can start giving different names for all these parts, but don't do that. Okay? As soon as I put X here, can you tell me what can I write here? Yes, what can I write here? So you see, I usually do this. I start giving a name for the very middle one. And then I will start reading the text. I know that between biology and physics, how many students are there? Biology and physics, 72. Yes? When I call this part X, then what will be this part? I can call it Y, but don't bring many variables inside. Yes? So what can I write for this part? 72 minus X. So it's a very bad drawing, but anyway, 72 minus X is this part. Okay? And then we go here. What can I write for this part? This is between biology and chemistry. Biology and chemistry includes 90 students. If I take this one to be X, what happens here? It's 90 minus X. Okay, what can I write for this one? Okay, now you know the sum of these things. How many of them are there? So I take this one, add it here, and add it here. What do I have? 90 minus x plus 72 minus x. So what the answer is, it is 162, and x are gone, so it's minus x. But I know that biology students are 250. So what is left here is 215 minus 162 minus x. Agree? Because if I ask what is this number, I start adding these numbers, so I get the total number of students here. But I know the total number of students here is 215. So if I subtract them, it is the number of students left here. But if you do the subtraction, what is the answer? 215 is 38 and 53 plus x. Yes? So this is 53 plus x. So you see, still I have only one unknown, and that is good. And I will do the same thing here. Okay, let us just do this. This is x. I want to see how many students are here. This overlap is between physics and chemistry. Physics and chemistry is 60. X of them is here, so 60 minus x of them are here. Okay, and then if I ask you, what should I write here? This is also easy, because I start adding them. 72 minus x plus 16 minus x. So this x and that x are gone, so this becomes 132 minus x. And then I know the total number of people in physics, or 100 is 173, so I subtract it. So what the answer is? This one minus that one is 41, yes? And then plus x. So here is 41 plus x. And the one thing is left, and that is this part. But this part, I have this one and that one and that one. In total, it's 90 minus x plus 60 minus x, which becomes 150 minus x. But the total number of students in the chemistry part is 182. I subtract it. So 182 minus 150 minus x is 32 plus x. I'm not saying this is the best way I'm doing it. Might be you can find a smarter way to do it. But this is usually works. I start with the middle one and give it a name, but I do not try to bring a lot of variables in, then I will get confused. And then I will use the information given in the problem, try to write everything in terms of only that single variable. So this is the general strategy. Might be for some special cases you can find a smarter way. Just do it, because that's not a rocket science. Yes, you can just try to understand it. But then there is still x is missing. Okay, which information? So you see which information I have used. Have I used this information? Yes. When I was calculating this part, yes. I have used this information, this, and that, and also that one. So this one is I haven't used yet. So this means that I have to use this one to find that little x. How can I find that? There are in total 380 students, yes? And then 9 of them does not study these subjects. So what is left is 371 students. Okay, so 371 students should be equal to what? How should I should equate it to what? The total number of people inside these circles. Okay? So this means that you have to add them up again. Yes, so it means that it is, what do I have? By the way, you don't need to bother to add them up. I don't need to bother myself to add these up, because when I add them up, it becomes the number of B. But I already know the number of B is what? 215. But don't get confused. So let me just highlight these things. I already calculated. But this I have to add these three parts. Yes, so it is what? Plus 41 plus x plus 60 minus x plus 32 plus x. And this is your equation. So 371 minus 41 minus 215 minus 60 minus 32 is x. Yes, because this minus x and x are cancelled. And one x is left, and I moved all the numbers to the other side. And then hopefully, if I haven't done any mistakes, we calculate this. So what is the answer here? This is 330, am I right? 330 minus 32 is 298. 298, and on the other hand, this is 275. 75 to here is 23. Yeah, so x becomes 23. Yeah, if you have calculator, please confirm that. Anyway, so x becomes 23. But this is not the answer. What is the answer then? The answer is, I know that x is 23. Do you remember I was supposed to find the students here plus the students here plus the students here in total. Okay, then it is clear. Instead of x, I put 23. This becomes how many? 76. 76 students are studying only biology. And then 41 plus x people are studying only physics, but x is this one, so this becomes 64. And 32 plus x are only studying chemistry, so if I put 23 there, it becomes 55. And you add these three numbers, you get your answer. So this is the number of students who are studying only one of these subjects, exactly one of these subjects. I told you, this is not the only way. Might be you can find another way that is also helpful. So this is clear that you need. And you see that formula that actually Gustav mentioned, and we proved that it is not that useful here. Yes, because that formula only tells you the number of students in the union. Here you don't need that, yes? Okay, any questions? Okay, thank you.